So at this point, we already achieved quite a lot. But there's one thing which is unrealistic, at least in some applications. Currently, we're always fetching data when this button is pressed. Now, in a lot of applications, you want to fetch data as soon as a certain component loads, right? If a user visits the web page, you immediately want to start fetching data. And currently, we're not doing that here. We're just fetching it on demand when the button is pressed. Now, to immediately fetch it, we can use another concept we already learned about. We can use the UseEffect hook. Because sending this HTTP request is a side effect which ultimately changes our component state. And you learned that such side effects should go into UseEffect. Having them into a function is of course also fine, as long as you don't just call this function as part of your main component function. Because then you could create an infinite loop where you call this function, it updates the state, the component function re-renders or is re-evaluated, and therefore the function is called again, it updates the state, the component function is called again, and so on. We want to avoid that, and that's why we use UseEffect for that. UseEffect is great if we have code that should be executed as part of the component render cycle, but maybe not always when the component re-renders. And therefore here, we can add UseEffect and then define our effect function here, either as an arrow function or as a regular function with the function keyword. And here in UseEffect, I can of course simply call fetchMoviesHandler. I can simply call this function like this. So now this function is still called if I click the button, but in addition also whenever this component is re-evaluated. Now, of course, I don't want to call it whenever this component is re-evaluated, because that would be this infinite task, which I don't want. Instead, we add our second argument here, which is this array of dependencies, where we define when this effect function should be executed again. It will only execute again if the dependencies listed here change. Now, as you can clearly tell, I didn't add any dependencies yet. So if I save it like this will never run again, except for the very first time the component is loaded. So hence, if we reload this app, the data is fetched immediately. It's still fetched again if I click the button, but it's also fetched immediately when this loads for the first time, because of UseEffect. Now, technically, we're not executing this in a clean way, though. You also learned that it is a good practice and a best practice to list all dependencies you use inside of the effect function here in the dependencies array. Now, I am referring to the fetchMoviesHandler function here. That is a dependency of this effect. So we should add fetchMoviesHandler, a pointer at this function, as a dependency. Because if this function changes, this effect should be re-executed. And this function could change if we would be using some external state in here. We aren't doing that in this example, but in other examples we could be doing that. So we definitely want to list this function, a pointer at this function, as a dependency of this effect. The problem with that is that functions of course are objects, as you learned, and therefore this function will technically change whenever this component re-renders. So we will create an infinite loop if we add it as a dependency. One solution would be to omit it, because here that would indeed achieve the result we want. But it could introduce subtle bugs if our function would be using some external state. So the better solution is to use the useCallback hook and import that from React and wrap the fetchMoviesHandler with that. For this we need to transform it and turn it into a constant, which saves the result of useCallback, which then wraps this function, which is now written as an arrow function here, though we could also use the function keyword, like this. And we should add our dependencies array for a useCallback as well, and list any dependencies this function might have. This function, though, has no external dependencies. The fetch API is a global browser API, it's not a dependency, and other than that, we're not using anything special in here. These state updating functions, as you learned, don't need to be added as dependencies because React guarantees that they will never change. Now, I still changed something which would break the app, I removed the async keyword. We need to bring this back here, simply in front of this anonymous arrow function. Async, then any parameters we might be getting, then arrow, and then the function body. Alternatively, we can also write it in a non-arrow function way like this if we want to. That both works, and there is no difference here. I will go back to the slightly shorter syntax though. So now we ensure that this fetchMovies handler function is not recreated unnecessarily. So if we save that, it now crashes though, because the order is now wrong. With the function keyword, it was no problem because of hoisting. Now, since this is a const, calling it before this code has been parsed won't work, so we simply need to move this UseEffect call after this function definition. And now it will work again. And it works as before, without an infinite loop, and we still can also reload manually. So that's how we can leverage UseEffect to make sure that we send a HTTP request immediately when a component loads, and not just when a button is clicked, though we still can also do that. And you also learned how to use UseEffect correctly then, and how to ensure that it will really always run when it needs to run, but not when it does not need to run. Now we know how to send a GET request, because that's what we're doing here. We're getting data by sending this fetch request to this URL. Now, in reality, in a lot of applications, you don't just want to fetch data. You also want to send data to a server, for example, because a new user was created. That's why I added a new component, and attached you find an updated project snapshot, which contains the new addMovie.js and addMovie module CSS files, and an adjusted app.js file, where I basically now also added this addMovie component here in my JSX code, and where I added this addMovieHandler function, which just logs the movie. In addMovie, I'm just rendering a form, and I'm gathering the user input, preventing the form default, the submission default, and then creating that movie object and passing it on through my prop here, through onAddMovie. Therefore, we get this form, and this would allow us to add a movie. Now, the Star Wars API, which we're using here, is really just a dummy API for getting data. We can't send post requests there, which is what we need to do to store new data. But this dummy Star Wars API, of course, is just some API which is there to play around with it. They don't want data to be submitted by anyone out there. So we can't send a post request here. That's why I'll now use another dummy API, another service. And that service is Firebase. Firebase is a service provided by Google, and it's in the end a backend which we can use without writing any code. Unlike the name implies, it's not some kind of database. It's a backend that comes together with a database, but it also gives us a full backend app, a complete REST API to which we can send requests. And the great thing is that we can get started for free here, also if you check their pricing pages, and we can play around with our dummy backend here for free, without writing any server-side code. Since this course is a React course, I of course want to focus on React. And here we will then be able to get data and to store data. For that, you need a Google account, and then you need to go here to the Firebase console after logging in with your Google account. Once you logged in, you can add a new project and give it any name of your choice. Here I'll name it React HTTP, but the name is up to you. Click continue. You can disable Google Analytics, we don't need them here. And this will now create our Firebase project. Now again, Firebase is a service offered by Google. It consists of many products and services that make up the overall service, and we will only use a fraction of that. We're not going to build some complex Firebase app here. I'm just using it because it's a free to use, no code needed backend, which we can start with. Now here I'm in the Firebase console, and for us, the real-time database is interesting. Now I did say that Firebase is not just a database, and it isn't. But part of its offerings is a database. They actually have two databases. Cloud Firestore is the more powerful one, but real-time database is the one which is easier to get started with, and since we just want a dummy backend, we'll use that. It also has the nicer REST API. Now once we click here, we can click on Create Database, and then, important, Start in test mode. Otherwise, you will not be able to send requests. Now this sets up a very simple database for you, and it gives you a URL which you can use to talk to that database, though that's deceiving. As I mentioned, our frontend won't directly talk to the database, and it's not doing that here either, even though it might look like it is. In the end, this here is a URL to some Firebase API, some Firebase REST API, which then takes incoming requests and does talk to some other database behind the scenes. It just might look like we're directly sending requests to a database here. Actually, we aren't. Now we can use this URL to send data to our Firebase backend and to our database, therefore. But of course, fetching movies from there won't really succeed. If we go to app.js, we can replace this Star Wars URL with this URL, and then actually add one extra segment here, which is movies.json. Now this name, movies in my case, is up to you. This basically will then just create a new node in that database, basically. It's a dynamic REST API, which you can configure here by using different segments to store data in different nodes of your database. So this name is up to you, and I choose movies because I want to store some movies. A .json is important here. That's something Firebase specific. They need this .json at the end of the URL you are sending requests to, otherwise your requests will fail. Now we can get our data from there, but if I use this URL, indeed we'll fail to get our data. And we actually get an error because I try to read some results which we don't get. We are not making it into this if block here because we're not getting an error response code. We do get a 200 response code, but we won't have our results in there. We won't get any data at all. Of course, because currently we're not storing any data here. Now I did switch to this real-time database and to Firebase so that we can send post requests and that we can store data, because that's also something you often gotta do, and that's something I want to show you therefore. So how can we send a post request when we click Add Movie to submit that movie data we collected to Firebase? Well, we already got this Add Movie handler, which is in the end triggered when Add Movie is clicked. And there we get a movie object, which in the end contains a title, an opening text, and a release date. An ID will be added by Firebase automatically. So in the end here, it's in this Add Movie handler where we want to send another HTTP request by using the fetch API. And I mentioned, even though it's called fetch, it's not just there to fetch data, you can also use that same function to send data. Might sound strange, but that's just how it works. Of course, by the way, you could also outsource some code into separate functions, maybe also store it in other files to keep this file lean. Here, for education purposes, I'll keep it all in one file. So back to Add Movie Handler. We want to send a request. And of course, I want to send it to the same URL which I use for getting my data. Otherwise, getting would never succeed. But I said that fetch by default sends a GET request. And here we now need a POST request. The fetch API works such that you can pass a second argument to fetch. And you can use that argument to configure this outgoing request. And for example, you can set the method key. By default, this is GET. But here we can set it to POST to send a POST request. And if you send a POST request to this endpoint at our Firebase service, Firebase will go ahead and create a resource in the database. Now, what happens exactly when sending a POST request to some URL always depends on the backend you're using. It's not set in stone that sending a POST request will always create a resource, even though it typically will. But it always depends on the concrete API. Here, for Firebase, sending a POST request will create a resource. So we also need to add that resource, which should be stored. And we do that with the body option here on this fetch API configuration object. Here I want to pass on my movie, though body doesn't want a JavaScript object like this. Instead, it wants JSON data. I mentioned before that JSON is this data format which is typically used for exchanging data between frontend and backend. Now, to convert a JavaScript object to JSON, we can use a utility method which exists in JavaScript. We can use the JSON object, which is built into browser-side JavaScript, and call stringify. And this basically takes a JavaScript object or array and turns it into JSON format. Now, last but not least, we need to add some headers, or to be precise, one header, which we do by adding the headers key and setting an object as a value. And that's the content type header, written like this, which should be set to application JSON. Technically, this header is not required by Firebase. It would be able to handle the request even if that header is not set. But a lot of REST APIs to which you might be sending requests later might require this extra header, which describes the content that will be sent, and therefore setting it is not a bad idea. And I will set it here even though it's technically not required. And with that, we'll send a post request with that data to this URL. Again, this will be an asynchronous task and we get back a promise, so we can again use async await here to await our response. And then we can also get our response data by awaiting response.json, because Firebase also sends back data in JSON format. And for the moment, we can console log that data. Now, of course, we could also add error handling here, and also wrap this with try catch, and do the same as we did before. Set error if we get an error, and so on. I'll not do that here though, because I want to keep this short and focused, but we could do exactly the same as we did before for getting data. Now with that though, we hopefully do store some data. So if I now reload, I can try entering a title here, my first movie, and some text here, and some release date of our choice, doesn't matter at all, and click Add Movie. And now let's have a look at the Firebase backend. And here in the real-time database, you should see a new Movies node, because we sent this request to /movies here. And in that Movies node, you find this cryptic ID, which was auto-generated by Firebase, and there you find the data which was sent. So this worked. In the React app, if you open the developer tools, in the JavaScript console, you should also see the response object you got back from Firebase, and there Firebase replied with that auto-generated ID, which was stored in some name field. So this is how we can send a post request. Now, if we click Fetch Movies, it should be able to get back some movies, but of course our logic for transforming these movies doesn't work anymore. Previously, we expected that we have a results field in our result, but now actually that's not the case anymore. If I console log the data we get back here when fetching movies, if I console log that, you will see that if I reload, the data we get back is an object where we have the cryptic ID as a key, and then another nested object with the actual movie data. So we're not getting back an array, but an object, where the IDs are keys and then the data are nested objects. So we just need to transform this appropriately to again display our movies. So therefore here, we're not using map anymore. Instead now here, we could simply create an array, loaded movies, which initially is empty, and then create a for in loop to loop through all the keys in data, because data is now an object, as I just mentioned, and keys are the IDs of the movies, actually, as you saw here. And then we simply want to go to loaded movies and push a new object for every key value pair we got in the response data, and set ID equal to key, set title equal to data for the given key dot title. So here we're drilling into that nested object we got in the response. We're drilling into this object here. where we have a title, opening text, and release date. This is how we dynamically access a property in JavaScript. And we're doing that for the title, for the opening text, and then also, last but not least, for the release date. Here we also do that like this. And there would be other ways of writing that transformation logic, but this way is hopefully very easy to understand. So then we got our loaded movies, which now again is an array full of objects which have the structure we expect. And therefore we can now get rid of this code and set our movies here equal to loaded movies, which is this array we just built. And with that, if I reload, you see that data is now loaded. And if I now add a second movie with more text and a release date of 2022, sometime in August, I can click add movie. And if I fetch my movies thereafter, I get this second movie as well. And of course, you could now tweak this app. You could make sure that new movies are fetched automatically after a movie was submitted. You can add error handling in the add movie handler. You can do all of that, but this is just a demo to show you the core parts that are involved when it comes to sending HTTP requests. And you now saw how you can set a GET request here to get data, and how you can send a POST request to store data. Both matters in many applications, and now you know both. And you also know how you can handle different states and errors. We didn't do it here for add movie handler, but it would work in exactly the same way as for getting our movies with fetch movies handler. And that's it for this module. Now you learned that React is able to talk to a backend, but not to a database directly, for security and performance reasons. But you can send requests to backend APIs. Very often that will be REST APIs like we see it here. And then you can, for example, use the fetch API or third-party libraries like Axios to perform that request, and to then also get the response, analyze the response, and maybe throw and generate an error if it's needed, and or work with the data you get back as part of the response. You learned how you can send both GET and POST requests, and you also learned how you can handle different states which are involved with sending requests. A loading and an error state, and the we have no data state, as well as the we do have data state. All of that is important and allows you to build rich user experiences, which you want to have in most of your applications, of course. Because sending HTTP requests is a crucial task, and here in this demo, you learned how it generally works.